In this video, we're going to talk about solving an absolute value equation and an absolute value inequality. We're going to take some time to think about what the absolute value represents, and we're going to apply that to our solving. Okay, so there is a property that's listed in your book that you can read here. I like to use the definition for absolute value. This is a number's distance from zero on a number line. And I usually just start out with a really simple example just to kind of demonstrate that to you. So if you were to draw a number line, here's 0 in the middle. This equation says I'm looking for numbers that are 5 units away from 0. Right? This 5 is a distance. That's why it's positive. So I really have two options. 5 units away from 0 on the right, or I could be 5 units away from 0 on the left. Okay. So when I'm solving with an absolute value, I'm always going to have these two, call them cases, right? One where I just take off the absolute value bars, right? So x could be 5. The absolute value of 5 is equal to 5, okay? Or x could be negative 5. Because the absolute value of negative 5 is also 5. So I have two options. One where I just take the absolute value bars off. One where I take the absolute value bars off and I change the sign of the number on the right-hand side. Okay, so let's look at what that means when I solve an equation. Let's see here. So to solve an equation, I'm going to isolate the absolute value, and then I'm going to use this idea to separate it into two cases. And I'm going to solve both equations and I usually get two answers for these. Not always, but many, many times. Okay. One thing I was wanting to say about the number line, the way this relates to the graph is the fact that we have that V shape. And that V shape, I'll just sketch it off to the side, has two sides. And so when I'm looking at where we could sort of look horizontally here at where the y value is 5 for this V, and I would hit, if I drew a horizontal line, I would hit the V in two places, right? And if I were talking about 5, this would be at negative 5 and at positive 5. So those two answers that we get are very much related to the two sides of the V. Okay, so let's try this one out. So we have the absolute value of 2x minus 5 minus 2 equals 1. The first step is to get the absolute value alone. So we'll move this 2 over to the right-hand side by adding. And then we're going to separate this into those same two cases. One where I take the absolute value bars off, and the second where I take the absolute value bars off and I set it equal to the opposite of this number on the right. Because in order to take the absolute value and get 3, this stuff inside could be equal to positive 3, because the absolute value of 3 is 3. Or this stuff inside could be equal to -3, because when I take the absolute value of -3, I also get 3. We're kind of using these two cases to represent those two possibilities. Okay, and then I want to solve each of these to get the two answers. So I'm going to add 5 to both sides. And divide by 2. Kind of out of space, so I'm going to write it up here. Same thing on the second case. I'm going to add 5 to both sides. And divide both sides by 2. So I get two answers, x equals 4 and x equals 1. Okay, so that's the process to solve with an absolute value. When I have an equal sign, right, I break it up into those two possibilities. Let's try one more. This one's from your book. This time we have 5 minus the absolute value of 4x plus 3 equals 2. So at the beginning here, we want to do the same first step. We want to get that absolute value part by itself. So I need to move this 5 over to the other side. So I'm going, it's positive 5 right now, so I'm going to subtract 5. I'm still going to have this negative sign. So I'll deal with that in a second. Okay, think of this as -1 multiplying this absolute value. So I want to move it over to the other side by doing the opposite. So I'm going to divide. And then I want to break this into my two cases. The first case is as is. Take out the absolute value. The second case is to remove the absolute value and make this right-hand side negative. That also is a 3 this time. That's kind of interesting. Okay. Notice what I didn't do. I didn't change the sign of what's inside here, right? These are both still 4x plus 3, okay? That's probably the most common mistake, so just be careful about that. Make sure you're forming your two cases correctly. That's kind of the key part of this solving process. There is another way to break it up into two cases where we take the negative of the whole thing that's here, which would mean you would change the sign of both parts that we have inside here. Right? You're welcome to do it that way, but make sure you research it and make sure you set it up correctly. Check with someone first, okay, before you come to take the test. All right, and then we want to solve these just like we did before. So we'll subtract 3, divide by 4. 0 divided by anything is still 0. Same thing on this case, subtract 3. And divide by 4. I can reduce this by dividing top and bottom by 2. So this will be -3/2. Or if you'd rather write it as -1.5, that's fine too. These would be my two solutions. Okay, so you've seen how to solve with an absolute value equation. Now let's take it one step further and look at an inequality. So just to show you the way an inequality operates, we'll take a look at these two pretty simple examples so you can get a kind of visual idea. I'm going to go back to that number line as our basis. Okay, so if the absolute value is a distance, we're looking for numbers whose distance from 0 is less than 5 units away. So that could be the number 1, 2, 3, 4, 4.99999, okay, up to, but not including, because I don't have the equals bar, the number 5. So open circle there, right? So all of those numbers, even if I picked a random decimal in the middle, right, 1.87 would be less than 5 units away, okay, all of these. Likewise, I could be up to 5 units away on the left-hand side as well. So -1, -2, 3, 4, up to, but not including -5. All of these would solve this inequality. Okay, and we've actually talked about 2 parts. Right? So we have the same 2 cases for an inequality. We have x values or numbers that are less than 5. This is sort of what we were talking about over here. And at the same time, we have numbers that are greater than -5. So when I make my first case, I just take off the absolute value bars. When I make my second case, I make the 5 negative, and I flip the sign. If the absolute value is on the left, and it's a less than, then it's going to be an and I could write my final answer as a double inequality. X is in between -5 and 5. We're going to write our solutions with interval notation. So in this case, we're just less than, not equal to, so round parentheses from -5 up to +5. Okay, so there's another option. Maybe I don't have a less than, maybe I have a greater than. How is that different? The way we form our 2 cases is going to be the same. Okay, so now I'm looking for numbers whose distance from 0 is more than 5 units. So these would be numbers like 6, 7, 8, 9, 10. All the way up to infinity. Okay, so x could be greater than 5. That would have a distance from 0 that was bigger than 5 units. Or I could have a number less than -5. So -6, -7, -8, all of those would be more than 5 units away as well. For both of these, we have kept it the same for the first case. For the second case, we have made the 5 negative and flipped the sign. Okay, so it's the same for both, the setup. But the result that we get on the number line and in our interval notation will look different for a less than compared to a greater than. Okay, and we could write this in interval notation. So going from left to right, we're going from -infinity up to -5. Just greater than, not equal to, so around parentheses. A union would be appropriate here. And then from 5 up to infinity. If the absolute value is on the left and I have a greater than symbol, this is an or. which means that I'll have two separate groups of numbers, and I'm going to write them together with this union as my solution. Okay, so let's take this idea and apply it to solving an inequality. The steps to solve an inequality are basically the same as an equation, but the way we form our cases and the fact that we're going to use interval notation for the final answer makes it look a little bit different. Okay, so we're still going to isolate the absolute value. Then we're going to separate it into our two cases, remembering to flip the sign for the second one. We're going to solve both. Really, there should be a fourth step here. I'm going to add that in. We're going to write our solution using interval notation. Okay, so let's try that out on this one. For this first example, the absolute value is already by itself, so we can go directly to breaking this up into two cases. So the first case is as is, x minus 6 is greater than or equal to 2. The second case, I'm going to make the 2 negative and flip the sign. So I have x minus 6 is less than or equal to negative 2. Now I'm going to solve both of these by adding 6 to both sides. So x is greater than or equal to 8. And x is less than or equal to 4. Okay, I always like to emphasize that it's good to sort of manage your expectations, what to expect. Okay, remember we said if the absolute value is on the left and we have a greater than symbol, then we can expect there to be two separate parts to the solution. This is an OR, like the one we just did. So these shaded regions are going to go in opposite directions, I think you'll see. So if number is greater than or equal to 8, so that's 8 and up. And then I want x values less than or equal to 4. So that's 4 and down. Okay, and we have two separate shaded regions here. So when I write it in interval notation, I'm going to go from negative infinity up to 4, and I have the equals bar this time, so I'm going to use the square bracket, a union, and then the square bracket again from 8 up to infinity. Okay, so hopefully this looks similar to solving an equation. But with an inequality, there are some differences. I think you can pinpoint those as well. Let's try a second one. Okay, so now we have 2 times the absolute value of x minus 3 plus 1 is less than 5. Remember that first step, it's very important, and that is to get the absolute value part by itself. So I want to start by moving this 1 over. So I'm going to subtract 1 from both sides. Okay, and I think sometimes folks ask me, can I distribute this too? If the number is positive, you probably could do that without a whole lot of trouble. If this number out front were negative, then that would be really sticky, and I don't think that would work well. So I always recommend just dividing by that 2. Could you distribute it here? Probably, but I think as a general rule, it's probably healthier to think about dividing on both sides. Okay, and then we're going to separate this into our two cases. X minus 3 is less than 2, and x minus 3 is greater than negative 2. And then I want to solve both of these. Get x by itself by adding 3. This is something we have to solve, right? I don't get necessarily numbers that are just opposite of each other here. I don't know if that's worth mentioning, maybe. Okay, and same thing here if you want to sort of think ahead or begin to manage what you think is going to happen. You could either look at the original or here. Maybe this is the best place. So once I've got the absolute value by itself on the left, I have a less than. A less than means I'm going to have an and, so that when I start to shade, it's going to be one region of the number line. And I really could combine these together if I wanted to. So I need numbers that are greater than 1 and at the same time less than 5. Notice they're joining together. They're not crossing over through to the arrow, right? That wouldn't be appropriate here because it's an and. Okay, and then we'd write our solution in interval notation. I do not have the equals bar this time, so I want to do the parentheses from 1 up to 5. All right, great. I hope this gave you a lot of explanation on how to solve with an absolute value. I hope you'll give it a try. Try some problems out at home. Think about that V shape and how this is connected to that. And good luck.